Hello everyone, myself Vedika Dilip Gaidi, rule number 6218. So today I'm going to present you before an enzyme called as DNA ligase. And enzymes are nothing but catalysts which speeds up the reaction in a living cell. We can call ligases as molecular glues because they speeds up the reaction or catalyze the reaction, but they join two larger molecules and then form a new bond. So what is DNA ligase? DNA ligase is also the same. It catalyzes the formation of bonds, but here it is phosphodiester bond and it works on DNA strands. DNA ligase can facilitate in joining of DNA strands and catalyze the formation of phosphodiester bond. We can use them in both DNA repair and DNA replication techniques. This was first discovered by Lehman, Guillory, Richardson and Hurwitz laboratories in 1967. These enzymes have a very simple mechanism. First, the DNA segments, nicks in DNA segments are recognized, and then and the DNA ligase enzyme is activated using ATP and pyrophosphate is released. In the second step, the ligase enzyme which is activated and the AMP complex is then transferred to 5' phosphate, which is also called the donor one, and the ligase enzyme is released. And in the final step, which is DNA ligation, the phosphodiester bonds will be formed because 5' phosphate group will be attacked by 3' hydroxyl group and the phosphodiester bonds will be formed in Nexa seal. As you can see down below the mechanism DNA ligase reaction, there are two different strands of DNA, and DNA ligase is working on it, and the final product will be of 3' and 5' phosphodiester bond. This enzyme has various application in various fields like biotechnology, cloning, next gen DNA sequencing. They can also be used in recombinant DNA cloning. As we call them as molecular glues because they join two larger molecules, they can be used to maintain genome integrity. The E. coli DNA ligases can be used for high efficiency cloning of full length cDNA. There are also some Taq ligases which we can use in amplification reaction because of their thermostable properties. So, uh, these enzymes have common sources from E. coli and bacteriophage T4. So, at the last corner, there we can see the structure of DNA ligase. They have four-stranded parallel beta sheet flanked by three alpha helices.